So, working on exponent laws, which is 1.6, we're starting off with x to the m times x to the n. Notice that both of these have the same base. We all remember what base is? So the base is x. When you have the same base and you're multiplying two powers with the same base, that means we add the exponents at the top. That's our first exponent law. So this unit or this section requires a little bit of memorization because this is a rule that you'll have to know, but we're going to practice it a lot, so I think that'll be okay. So let's take a look at what an example of that might look like. -2 times -2 to the 5. First of all, if it just says -2, which exponent would be on there? We never write it, but what's actually up there? Up here. There would be a 1 there. We just never write it down, right? So if there's nothing written there, we know it's an exponent of 1. So in my answer, what's the base going to be in the answer? The base stays the same, so it's still -2. And then what do I get for my exponent if I have a 1 there and a 5 there? -2 to the power of 6. And, well, let's practice some of our skills from before. If I have the -2 in brackets and an even exponent up top, is the answer going to be positive or negative? It's going to be positive. And it's going to be like thinking of 2 to the power of 6. Do we know 2 to the power of 6? What is that? What's 2 to the power of 6? So 2 times 2 times 2 times 2, 6 times. What is that, Mitchell? It's going to be 64. Everybody agree with that? Normally, something to the power of 6, we probably wouldn't just know off the top of our head, but if the base is 2, it's reasonable to know how to, or to sit there and think your way through what 2 to the 6 would be. So that would be our answer. Okay, so if that's the exponent law and we know that that's our rule, what's the base in this next example? 2 to the a plus 2, so this is a little bit weird in that we have a variable at the top. We have a plus 2 times 2 to the 4, so our new base is still going to be 2. And what do I do with these? Yeah, we add them, so it's going to be a plus 6. Because we did a plus 2 plus 4, so it's just the 2 and the 4 that we're adding together, so we get 2 to the a plus 6. How about the next one? 3 to the ab plus 1 times 3 to the ab minus 3. So we have to sort of think our way through this. What do we end up getting when that's the case? 3 to the ab plus 1 times 3 to the ab minus 3. So the base is going to be 3. And then we're looking for our like terms. Do you see if we're adding these, it's like saying, how many ab's do I have? ab plus ab. How do I write that, or what does that mean? It's just 2ab. It's like you're counting up how many ab's you have. So we would say, this is too thick. That's my problem. Let's fix it. So we have 2ab, and then for the other part, plus 1 and minus 3. When we add those together, what am I left with? 1 plus -3. What is that? One plus -3? It's going to be -2. Everyone good with that? So the answer, because there's nothing else we could do with this, it'd be 3 to the power of 2ab minus 2. that's how we would leave this, because we don't know what a and b are. So we leave variables in our answer for our expression. Okay, so now let's move on to something that has a little bit more going on. In this example, you take a look at that. We have 2 to the 5 minus 2 to the 3 times 2. So we kind of have BEDMAS and we have our exponent laws. So there's quite a bit going on here. By looking at the big picture of all of this stuff, which part do I need to start with first? The multiplication. So we've got to deal with this part first. We can for a second just ignore the other part. If I just dealt with this part, we know it's kind of like there's a 1 there. But if I combine those, what do I actually end up getting there? It's going to be what? 2 to the power of 4, because we simply add them together. Then we bring back the part we were ignoring, so we still have the 2 to the 5 minus this. Where do I go from here? Are there any laws or rules that we can use for this when we're subtracting? Not that we've learned so far, we've only learned the 1. So we can simply, because the base is 2, we can actually calculate these. What is 2 to the 5? 2 times 2 times 2 times 2 times 2. Do you know now from practicing it off the top of your head, what is that? You can just call it out. 32 minus, what's 2 to the 4 then? 16. So after all that work, what's the answer for this? The answer for this is just 16 after all of that. Do you see that same step-by-step approach of breaking it down, dealing with one little part first, and then putting it all together? Okay, so the next law, or exponent law, is x to the m over x to the n is equal to x to the m minus n. So we are subtracting the exponents in this case. Notice that just like last time, the base is the same. We can only use the exponent laws if the base is the same. So having looked at that, what would be my answer for this first question? 10 to the 3 over 10 to the 6. My new base, or I guess it's not new, it's still 10, but what do I do with the 3 and the 6? According to this, I would subtract them. 3 minus 6. So what do I get? 10 to the... What's 3 minus 6? -3. But do we ever leave our answer like that? What is this the same thing as? So this is sort of summarizing a lot of the things we've done so far. How do I make that -3 positive as an exponent? Remember, how do we make a negative exponent positive? What do we do with the base? What do we... We can't make the base negative, but we do something with it to make this, to change this into a positive exponent. I sort of showed you with that. What do we do with it? What do we call that when we flip it? Yeah. Thank you. We find the reciprocal of this. So 1 over 10, and then that becomes to the power of +3. And what is 1 over 10 to the 3? What is 10 to the 3? Basically, the 3 tells us how many zeros we have. So it's 1 over 1,000. Good? And then we have a bit more going on here. So we have a to the m plus 1 over a to the m minus 3. This requires a little bit of thinking and a little bit of strategy. I'll start with this. What is the base in our answer? What is the base for both of these questions? Yeah. Sorry? A. So we're still going to have A. And what do I do with this and this? We subtract them. So I'm going to have m plus 1. And I'm going to subtract, and I have to put it in brackets because I'm subtracting the whole thing. Do you see why the brackets really matter? Because if I want to get rid of the brackets, I need to distribute the negative here and here. So it's actually going to change the sign of everything that's inside. So I would have m plus 1, and this becomes minus m, and this becomes plus 3. Does everybody see how we got that and why the brackets are so important? So then this becomes a matter of collecting our like terms. So if we go here, m minus m, what happens to the m's? Well, if it's m minus m, do you see it actually ends up canceling? So they're gone. And then if we have plus 1 and plus 3, it's going to end up being a to the power of 4. If it's just a divided by a, yes, it's equal to 1. But this is not just a. This is a to the m plus 1, and this is a to the m minus 3. Good question. So we can't, remember last day we talked about how the exponents are needy? They need to be attached to something. You can't separate those two. Yes, Alex? Yes, but the reason you're allowed to cross it out is because of this, right? It's because we're subtracting. Yeah. So once I teach you the strategy, if you want to take the shortcuts, no problem, but I want you to learn the proper method. Good? How about if we have something where we're sort of combining these rules that we've learned? We can ignore the bottom and let's just start by dealing with the top first. So it's much easier if we break things down into a step-by-step manner. If we just ignore the bottom, I just have the top, the base would still be this. What would I get if I just dealt with the top? 5 to the power of? What do I do to those two exponents at the top? Do I add them or subtract them? I'm going to add them. So what's negative 4 plus 3? Negative 1. And at the bottom, we have 5 to the 7. So in my answer, I keep the same base. I keep the base as 5. And then I'm going to subtract these. Negative 1 minus 7. Everybody see that we're still doing the same thing. It's just we now have a few more steps to work our way through. And what is negative 1 minus 7? Negative 8. And we never leave our answer that way. We want to leave it with a positive exponent. So what can I rewrite this as? If we have a negative exponent, what do I do to this? We flip it and take the reciprocal, so we make it 1 over 5, and that makes our exponent positive. And we, without a calculator, can't figure out 5 to the 8 easily, so we're going to leave it as 1 over 5 to the 8. I'm okay with you leaving it that way. If the base is 2, then you could maybe calculate it. If it's a reasonable exponent, go ahead and calculate it. If not, it's okay for you to leave it like this. Good? Question? Thank you. We can leave it like this, but that's great. And if you want to write it as the answer, that's good. Yes. And this is just a refresher. What is x to the 0? We already did this, but we can do a quick recap. What's anything to the power of 0? 1. Anything to the power of 0? 1. And if we have all of this, 4,321 to the power of x equals 1. Therefore, what is x? X has to be 0. Do you see how that fits together? You can do numbers 1 to 9, all of them,